Hi, my name is Leslie, and I'm here to explain the extinction timeline E1 through E5 on how the ventrotegmental area of dopamine signaling recovers with safe re-exposure. So this is my topic, and we're mainly going to be doing it based off of mice because that's what mainly the experiment was on. So what I'm going to draw here on this whiteboard. So give me 1 second as I kind of go over the timeline of the extinction process. So I will be adding on a graph over here. Right here we have our x-axis going across, and then we have our y-axis, right? So the x-axis will be labeled as the dopamine signal, and this is a very informal graph that I'll be adding on here. There won't be any numbers or such, which is why it's informal. But anywho, we have the y-axis will be extinction trials, right? Trials. And then we will be labeling as our E1, E2, E3, E4, and E5, right? So as I'm doing this will be then okay, give me one moment again as I'm drawing my figures. Right, okay, so now we are getting into the how of this experiment, right? So how was this experiment done? So in this experiment, researchers are studying and learning about the brain, specifically how we unlearn fear. Um, yes. Um, First, the subject learns that a cue or a tone or a light, right? In this case, we have our lovely mice, and let's use this, for example, to represent light, my colored markers. So if there is a tone or a light being shown on this mouse, it predicts that something is negative. So we can use a different color. So in this experiment, before what they did with mice, right? So before what they did with mice was that whenever this mouse was shown a light, it would get a negative cue, right? So because it got a negative cue, the brain signals kind of view that as like, oh, this is something to be fearful about. Because the cue that scientists were doing were, like I said, giving a negative cue to the mouse, so it learned to be fearful. So the brain forms an association, right? So the cue equals danger. So we shall put right here, cue equals danger. Yes, right? So um, then comes extinction, right? Which is what the figure focuses on. The researchers present the same cue again and again. So they do the same cue again, but now nothing bad happens, right? So we no longer have a negative cue. So as we are going to explain more about this, right? I'll use a different. So light is being shown again. So now we see that while this is happening, they record activity from the ventrotegmental area, right, or known as the VTA. This brain region releases dopamine, which helps signal whether things are going as expected or not, right? So as we go a little bit more detail, we'll go jump more specifically about the brain. So the VTA sends dopamine signals to other brain areas involved in learning and emotion, right? So like regions that process fear or decision making is not just about reward. Dopamine is tracking whether the brain's predictions are correct, right? So we will get into the what of the experiment, right? So we are getting more so of the graph. We'll explain how this experiment went about and how the extinction process was going and what were the dopamine signals. So, at the beginning, the brain still expects something bad is happening, right? In the beginning, we have this light being shown to this mouse. Again, remember before, they associated the cue, which is equal to danger. So when they got rid of that negative cue, they shone the light on this mouse again. And here is the extinction one process. Dopamine levels drop, right? Because it still has that fear, right? So the mouse expects that something bad is going to happen even when it sees the cue, but nothing happens, right? So here's the difference between expectation and reality. Because of that, dopamine activity drop, and this drops basically is saying that the brain is kind of like as if the brain were able to talk, the brain would say, "That's not what I predicted," right? Um, so then we see on extinctions 2 and 3, we see a rise in dopamine levels. So a few more trials was occurring towards this mouse. And then the brain starts to adjust. As we can see, as the dopamine levels are rising, it begins to realize that maybe this cue isn't dangerous anymore. So dopamine activity starts to recover, right? So this is like the early stage as we have for E2 and E3. But then we get into E4 and E5, right? So they continue to do this trial. And later in the trials, the brain updates its expectations. So now, instead of predicting danger, it predicts safety. So dopamine activities return to normal. So this would be the normal phase, right? As I switch markers. This would be the normal phase of the dopamine levels, right? Normal dopamine. Um, so, and it even increases slightly. So, we could also add that too. But what's really important about this figure is what happens when the subject sees the cue again after learning. So we see that dopamine responses are recovered. And this shows that the brain didn't erase the old memory, it just created a new one, right? It still remembers the cues. Our brain can't, forget completely um, on something that is like, I guess, not traumatic, but something that is fearful, right? But we learned that, and the scientists learned that, the brain reroutes itself to learn something new. As we go deeper, we could talk more deeper about the brain, like what's happening biologically. Is the brain constantly comparing predictions into reality? When something unexpected happens, like no danger when danger was expected, like dopamine signals, um, that difference. The signals help update connections into the brain. So the next time the cue appears, the response changes. And over time, this leads a shift to, um, or this leads a shift from a fear response to a safety response, right? So now, as we kind of see this experiment, we'll learn more about the why. So, what is the big conclusion with this experiment, right? So, the main takeaway is what we want to get from this extinction experiment is that this figure shows that extinction is not forgetting, but is learning something new, as I mentioned before, right? So, the brain is learning that something So the brain is learning that something that used to be dangerous is now safe. So dopamine plays a key role in this process by signaling that expectations are wrong and helping the brain update its predictions, right? So, um, kind of without the aspect of the mouse, right? We can use that in humans. An analogy that we can think of, that something that is related to this, is to think of a fire alarm, right? When you think of a fire alarm, you usually associate a fire alarm as meaning danger. There's a fire, or there's a gas leak, or there's something going on, right? So you react strongly, and you react kind of like what you're taught from school, which is to get up, either get your jacket, forget your things, and right away, like, shoot for the doors to go outside, right? But if the alarm keeps going off and then nothing bad happens, eventually you stop reacting, right? So this change is exactly what the experiment is showing within the brain, right? And then the overall is This figure shows that dopamine is not just about reward, which I guess we usually associate dopamine as relating to, which is just reward, or it's about, um, once you get something, your dopamine rises, right? But it's not just about reward. It's about learning from mistakes and updating what we expect from the world. So in this case, from the mouse, it realized that light was not is not a bad thing, and more exposure it got to it, the more it not forget again, because we don't want to say that the mouse forgot, but we can say that the brain rerouted itself to learn something new, and which is learning that the light isn't bad. Same thing with the analogy. If the fire alarm kept going off, we learn that the fire alarm is not bad, and we react less, right? So this is the overall extinction process. This kind of goes to show that, again, we're learning about the brain, and we learned that extinction trials is more of like a learning process to the brain, and we got to the researchers got to experiment more, and they got to learn more about how the brain works and how the dopamine levels contribute to this, which is my